Hi guys, I hope you are safe and well. In this video, we will discuss the basic magnetic force. Magnetic force. Magnetic force is the force of attraction and the force of repulsion exerted by the poles of a magnet and a moving charged particle. So in magnetic force, you have to remember four things. So magnetic force have four characteristics. Number one, magnetic force is proportional to the charge. That means 5 protons will have a higher force compared to 1 proton. The second one is it is proportional to the magnetic field. The higher the magnetic field, the higher the force. And the third one is it is dependent on the velocity of the particle. The higher the velocity, the higher the force. But if the particle is at rest, there is no force. And then we cross multiply. We can also use sine theta. So this is the general formula of magnetic force. But there is a fourth key, and that is the force doesn't have the same direction with the velocity and the magnetic field. So we have what we call the right-hand rule. So it would look like this. This is the velocity of the particle, your point finger. And the middle finger is the magnetic field. And your thumb will be the force. Again, if the velocity is moving in this direction and the magnetic field is moving towards me, the magnetic force will be moving in this direction, the upward direction. So that is the right-hand rule. So we have here a beam of protons with a charge of 1.6 times 10 to the negative 19 coulombs moves at 3 times 10 to the 5th meters per second through a uniform 2.0 Tesla magnetic field directed along the positive z-axis. The velocity of each proton lies in the xz plane and is directed at 30 degrees to the z-axis. Find the force of the protons. So we will use the force times QVB sine theta, or the cross product of charge, velocity, and magnetic field. So we have here the given. The charge is 1.6 times 10 to the negative 19 coulombs. The velocity is 3 times 10 to the 5th meters per second. The magnetic field is 3 Tesla, and then the angle is 30 degrees. So we'll just plug it in, and we have this, and it will result to 9.26 times 10 to the negative 14 newtons. So we have another one, and that is a magnetic force on a current. The formula is the force is proportional to the current, the length of the wire, and the magnetic field. So this is in amperes, meters, and Tesla. So this is the general formula. It also follows the right-hand rule. It will follow the right-hand rule. Instead that this will be our velocity, this will be now our current. Current, magnetic field, and the force. So if the current is going in this direction and the magnetic field is going inside in this direction, the force will be in the upward direction. So we have this example, a wire with 0.10 meters long carrying a current of 2 amperes is at right angles to the magnetic field. if the magnetic field strength is 0.20 Tesla, what is the force on the wire? First, we get the given. So we have here the length of the wire, the current, and the magnetic field. And we will use the formula. The formula is current, length, and magnetic field. And our final answer is 0.04 newtons. So I hope this will help you to solve the basic magnetic force. Thank you for listening.